Hello, welcome everyone. If you're here, hi, feel free to say hi in the chat and welcome. I hope everyone's keeping well. Let's have a little look. I've got the chat open, so feel free to say hello if you're here and want to say hi. That would be great. It'd be great to hear from everyone. I hope the summer's going well for everyone and we're kind of getting through the year kind of quite happily now that things are progressing. We've got a clearer picture, hopefully, about next year a little bit. So we're going to be looking at a GCSE topic today of simultaneous equations, which is quite a big one, quite an important one. Please do feel free to say hi. I've got the chat open and I'm going to share my slides shortly and we can get started. So yeah, it'd be great to hear from you all and I hope everyone's keeping well. Simultaneous equations is a big GCSE topic. It'd be great to hear if you've covered this before. And obviously any questions and answers as we go would be great. So feel free to share those in the chat as well. I'm going to share my slides shortly and we'll get working through some questions and some ideas. And it'll be great to hear from people along the way with answers and questions as we go. Cool. Right. So I'll share that with you now. And it'd be great to hear from you, as I said, if you can see the slides and any questions and answers as we go. So I'm going to share that now. Let's make sure, share the presentation. There we go. And that should be nice and full screen. So hopefully we can all see that. Excellent. So do say hi, as I said, in the chat if you've just joined. It'd be lovely to hear from people. And we're going to get started looking at this big topic, simultaneous equations, which you may or may not have seen before. So welcome to anyone that's just joined. Do say hello, and I'm going to get started now. So this is a really important GCSE topic that comes up on all the different exam boards. So simultaneous equations. And here we go. We'll get started. So to begin with, I'm Max, and I'm head of maths at Snap Revise, and I've did a maths degree a few years ago and I've been teaching A-level and GCSE and below ever since and do the web classes for Snap Revise and obviously on YouTube Live as well. So I'll talk a little bit about Snap Revise towards the end, but I'm keen to get started on simultaneous equations today. So that's enough about me on there. Here we go. So what we're going to look at today is understand simultaneous equations and their solutions, solve them, and use a method of substitution as well as a method called elimination. I'm not going to do quadratic simultaneous equations, but we'll look at what they are and how to solve them and sort of how to present and interpret the solutions. So do let me know in the chat if you've done simultaneous equations before, if this is something you're kind of familiar with. As I said, it is a really important GCSE topic that brings lots of stuff together. Welcome if you've just joined. It's good to see people are here as well. And we're going to get started looking at this topic now. So here we go. Welcome, guys. We're looking at simultaneous equations. And as I mentioned, this is a topic that appears on all the exam boards, Edexcel, AQA, OCR. It's a really important GCSE topic. So it'd be great to know if you guys have met this before. Do let me know. And as I said, as we go through, do share any questions and answers in the chat. So things we should already know, solving linear equations, for example, there's a couple here. Hi, welcome. Lovely to see the messages coming through. I'm going to get started now, but please do share answers and comments and questions as we go. And thanks to those that already have. Excellent. So if anyone knows how to solve the first one, this is just hopefully some kind of prerequisite knowledge and skills that we should be able to do for this. Hi, welcome, guys. Lovely to see the comments coming through. What we're going to do is the first one, 2x plus 2 equals 3x minus 1. In order to solve this, let me know what we would do here. So this is solving a linear equation. We're trying to find the value of x. If you've done this, you've got an answer, do let me know in the chat. And it comes from rearranging. So this is a really important skill for what we're going to do today with simultaneous equations. So some people learn it as balancing both sides out, do the opposite to each, so the same thing to each side, but we want to kind of collect the x's on one side and the numbers, the constant parts on the other. So for example, here we may choose to firstly add 1 to both sides and we come out with 2x plus 3 would be equal to 3x. And then feel free to share answers in the chat, as I said. And then if we minus 2x from both sides, we're going to get left with 3 is equal to x. So I basically took away 2x from both sides. And the value of x being equal to 3 solves this equation. Lovely, well done. Thanks, guys. That's excellent. So that's the first one done. And then the other, we do a very similar method. But remember here, to collect the x's on one side, the easiest thing would probably be to add 2x to both sides. And so what we would get is 6x plus 3 is equal to 15. Then we can subtract 3 away from both sides, not 3x, just 3. And we would get that 6x is equal to 12. And then if I divide both sides by 6, I'd get 1 lot of x is equal to 2. And that value of 2 would work in both sides of that equation. So if I plug that back into the original question, and I say 4 times 2 plus 3, that equals the same as 15 minus 2 times 2, which is 4. And the both sides are equal, so you know it's right. And that's a really good thing about a lot of these algebra-based topics. You can kind of guarantee you've got the right answer because you can sub your value in and check it actually works. So hopefully this is really clear, and this is something we've done before. It's a skill we're happy with. It very much feeds into what we're going to do today with simultaneous equations. So let's get started. The first thing we're going to do is look at solving simultaneous equations by substitution. So do let me know if you've seen this method before. Please feel free to say, yes, I've seen it, I've heard of it. And we're going to have a little go, but also share answers as we go if you're feeling confident or think, I know what to do at this stage. So we're going to look at solving by substitution. But just to start with, lovely, that's great to hear some people have done this before. What I'm going to do is just look at what a simultaneous equation actually is. So simultaneous equations are basically sets of equations, and we think typically that we're dealing with 2, but it could be more than that. We could have lots of different equations to deal with. So sets of equations in terms of multiple variables, and obviously the first thing we just did was we looked at solving linear equations with just x involved. But this is a little bit more advanced. This is involving multiple unknowns, which we're calling variables. And there is a solution. Basically, if it involves x and y, for example, typically we use those letters. We can think of that as the solution where the graphs of these functions intersect. Who has come across that idea before? That the solution to a simultaneous equation can actually also be found from their graphs. So the graphs of the functions, where the graphs of the functions intersect each other. Has anyone seen that or come across that idea? Intersect. Yeah, lovely. So yeah, absolutely. So here, if you're given a question where you're given two simultaneous equations and you're given their graphs, you can literally just read off the coordinates for x and y where they cross each other. And that pair of values for x and y must fit on both lines if it's where they cross. So it must simultaneously solve for one line and the other, so for both functions. So it is the point that works in both equations. So for example, here, the coordinate 1, 1, when x is 1 and y is 1, they're the pair of values that work in both of those lines simultaneously. So it's a really nice idea that actually, if you're given the graph, although some people struggle with graphs or don't like graphs, actually within the realms of this topic, it's a really easy way to solve simultaneous equations, because all you're effectively doing is picking off the point where they cross. And that is the answer. That is the pair of values, x and y, that work in both equations at the same time. So really actually quite a nice skill is being able to interpret from a graph the solution to simultaneous equations. So if you've seen that before, that's great. It's worth sort of reminding ourselves about that, because sometimes those questions come up and they're actually really easy to do when you know what you're looking for. So that's brilliant. So that's kind of what a simultaneous equation kind of question is. Solving by substitution is what we're going to look at now in a couple of steps. And then we're also going to look at this method called elimination. So this is very much an algebraic approach without using the graphs. So to solve simultaneous equations by substitution, what we basically do is we make x or y, whatever one is easier, x or y the subject. And please do feel free to work ahead of me and solve this if you can. But I want to go through the different techniques and the different ways to do it. So make x or y the subject of one equation. So the whole thing basically is equal to x or y, so that it's made as the subject. And then what we would do is we would substitute that thing we've just rearranged into the other equation. So for y or x, depending on what we just did, into the other equation and solve. And then this is the bit that a lot of people get wrong or kind of lose the final mark for, this last step. And the last step is also we need to find the other value as well, because there's kind of two answers here. There's a value for x and a value for y. So what we then need to do is substitute the value we find back and find the other variable as well. So substitute value back into first equation. And I'm going to do that here now. But as I said, feel free to work ahead of me and share any answers if you've done it. So this is a really, hopefully good one to look through and check that this method makes sense to you. So this method is called substitution, and I'm going to go through the steps as a nice example here. And well done if you've done that already. So for example, this equation, I could make x the subject, and I could say, well, if x plus 3y is equal to 4, then x must be equal to 4 minus 3y. So I've not changed it at all. That's the same equation. I've just rewritten it in a different way, whereby x is now the subject. And what I can do is I can replace x with all of this in the other equation. So I can say 2 lots of x, well, x I know is equal to 4 minus 3y. 2 lots of x minus y equals 1. So I've replaced x in here with the thing that I defined x as. And well done. So I keep saying excellent, and it's like I'm trying to make some sort of pun. But well done if you've got an answer for this. That's lovely. So now what we do is we've got an equation with one unknown, which we can solve. So I expand that out and I get 8 minus 6y minus y equals 1. And if I rearrange that, I get 8 minus 7y equals 1. So that means that if I move the 7y across and take away the 1, that will tell me that 7y equals 7. So y equals to 1. So just as a little pause, as a checkpoint, well done to those of you that have shared answers, and thanks very much for doing that in the chat, and giving it actually some of you as a coordinate pair or explicitly as x equals this and y equals this. We've found the value of y going through my method so far. And the way I did that is I made x the subject, put it in the other equation, got it all in terms of y, found that y is equal to 1. Now I can plug y back in to either of these equations, and I know that x plus 3y, 3 times 1, is equal to 4. So that means that x must be equal to 1 as well. So when x is 1 and y is 1, they're the pair of values that work in both equations, and you can check it in both, and they will solve it. So very well done if you found those answers. That was superb. That was using the method of substitution. It wasn't the only way algebraically you could solve this, but it is a really important and useful technique to know and be confident with. So very well done if you solved that. Let's have a look at a couple more, and I'll give you some thinking time. But some of these solutions might not be very nice numbers, and you can leave your answers as fractions or decimals. I would actually recommend leaving it as fractions in a lot of cases. That's lovely. Thanks for the comments, guys. Well, what I'm going to do now is some of these questions as we go are going to get a little bit more challenging, but I want to kind of make sure that we do ask any questions as we go So I'm actually going to start with this one because I think the solution's a little bit nicer, and then we can try, for those that are confident, the trickier question. So this one here, what I would recommend is, again, let's use substitution. Let's make x the subject of this. So if I add x across, x equals to 2y plus 1. So that might help start you off. And I would like to start with this one first because I know the solution is going to be a little bit nicer. So if you are feeling confident with this and you want to kind of work ahead of me and share your answers in the chat, please do. Please also ask any questions so that I can clarify any bits that are challenging. But thanks to those that have already done that and all the comments that are coming in. That's lovely. Right. So again, we're going to use substitution here. I've got x in terms of y. X is equal to 2y plus 1. If I replace that in here, I'm going to get 3 lots of 2y plus 1 minus 4 lots of y minus 5 equals 0. Now, this is good because I've now got an equation with only x's involved. Sorry, not only x's, only y's involved. So I can find what y actually is. I can just solve this normally. So 6y plus 3 minus 4y minus 5 equals 0. And if I solve that, tidy it all up, 2y minus 2 equals 0, 2y equals 2. So hopefully we're happy, y equals 1. Now remember, that's a lot of work already. We've only solved half of it. We've only found what y is equal to. What I can do now is I can take the value of y and find x, because I know x is 2 times y plus 1. So x is equal to 2 times 1 plus 1. So x is equal to 3. And they're the pair of values for x and y that solve these two equations. So it was the same method and it worked in very much a similar way. The fact that they were equal to 0, it was just the way that it was presented, but we still rearrange it to make x the subject, sub that into the other one, find y, and then go back and find x as well. So hopefully that's nice and clear. What I'd like to do now is, for those that are kind of happy with that, give this one a try. These solutions are a little bit nastier, but we're going to go through this question and then see how we get on. But please do ask any questions if you'd like me to clarify any of these steps. I am obviously going to go through this as well. I think this is a really good one to go through because the answers aren't as nice as the ones we just did. And also this topic, bearing in mind, could be a calculator or a non-calculator paper topic. So we have to kind of be aware that showing your steps is really important either way, but also anticipate that sometimes the answers might not be perfectly nice integer whole numbers. So what we've got here is x plus 5 equals 3y and y minus 2 equals 4x. So again, I like making x the subject. I'm going to do that to the first one. X is equal to 3y minus 5. Okay. The last step. Okay, thanks for the question there. No problem. Are we talking about this step here? Is that what you'd like some clarification on? And I do appreciate I did that quite quickly at the end. So just let me know if that's the bit you'd like me to just go back over. So the bulk of what we just did in the previous question was firstly finding the value of y. Now what I can do, just to clarify for those that are asking, when I found the value of y here, that's half of the answer, but it's more than half of the work. We've done the majority of the work. What we do at this stage is we substitute y in as 1 back into either of the first two equations. So if I put y as 1 into here, or into this version of the equation, it will allow me to find x. So what I did is I put y equals 1 in here. And I said, well, if I know y equals 1, 2 times 1, 2, plus another one is 3. So the value of x is 3. Because I plugged it into the easiest equation that I could choose from at the top to find the value of x. So it didn't really matter which of those equations you plugged into, which of the first two. I liked this version of the first equation because it just spits out x straight away. So hopefully that kind of clears it up. But basically you can plug that value of y into either of the equations at the start to then find the value of x that pairs up with it. But that was a brilliant question, because I do think there was less work in there at the end, and I went through it quite quickly. So thanks for asking about clarification on that, and hopefully that's helped. So you basically take the value you've just found, put it back into one of the first equations to help you find the other value. And a really good thing you can do is check that the pair of values also work in the other equation you didn't substitute it into, because then you know you've guaranteed you've got it right. So hopefully that's clear. Do let me know if you're still unsure. And what we're going to do now is this question here that is, as I said, some slightly trickier looking answers, but it's the same process. So here I've made x the subject, x is equal to 3y minus 5. And what I'm going to do is I'm going to replace x in the second one as 3y minus 5. So what I have in the second equation is y minus 2 is equal to 4x, so 4 lots of 3y minus 5. And here we go again, we've got an equation fully written in terms of y. So I can expand this, tidy it up and solve it. Y minus 2 is equal to 4 times 3y, so 12y. 4 times minus 5, minus 20. Now, if I rearrange that, if I add 20 to both sides, y plus 18 equals 12y. If I take one y away, 18 equals 11y. And if I divide both sides by 11, y equals 18 over 11. Now that doesn't look nice, but that doesn't mean it's wrong. So what I want to just clarify here is that really, I would say mathematically, it's nicer to actually leave your answers as fractions, because then you don't have to round it. You don't need to get a calculator out and work it out as a decimal. That's absolutely fine. And you could write it as a mixed number if you don't like top-heavy fractions, but that is the value of y. So it doesn't look as nice as the other solution, but we're still going with it. We're still using the same method. Now all I need to do is find the value of x. So I do the same thing again. I take that value of y and I plug it back in here to get x. So x is equal to 3 times y, 18 over 11, minus 5. So then we can calculate that. And 3 times 18 over 11, that's the same as 3 over 1 times 18 over 11. And then we need to minus 5 from that. And again, this could be a calculator or a non-calculator paper, but the solution we get here is x is equal to minus 1 over 11. Okay. So what we would get is we would get 3 times 18 over 11 is 54 over 11. And 5 as a whole number is like 55 over 11. So when you take 54 over 11 minus 55 over 11, you get minus 1/11. So we can see it's a nastier looking solution because the answers are fractions, but the actual method was identical. The approach was exactly the same if we use substitution. So it's worth looking at that harder question. Okay, I'm going to keep going, and I'm conscious of the time as well, because I do want to make sure we get on to the method of elimination as well. So just looking at these questions here, feel free again to work ahead of me, but I'm going to start working through these questions. And again, the answers might be not perfectly whole numbers, but we can still use this approach. So a bit of fractions becoming involved. So what I would do for this first one is I would still make x the subject. Now the problem is 2x equals 1 minus 3y. So that's not perfectly x on its own. So that means that x is equal to a half of 1 minus 3y. If I divide both sides by 2. And you could also write it as 1 minus 3y all over 2. Now what we can do here is we can substitute this in here for x. So 3x is 3 lots, 3 times a half times 1 minus 3y. Minus 2y is equal to minus 1. So what I would get here is I would get 3 over 2, or 1.5, lots of 1 minus 3y, minus 2y equals minus 1. So that would be 3 over 2 minus 9 over 2y minus 2y minus 1. And if, like a lot of people, fractions really sort of look a little bit daunting, or you think, I don't like when there's fractions, remember when you're multiplying fractions by a whole number, really all you're doing is you're timesing the numerator. And thank you to those in the chat sharing answers and questions still, that's great. So 3 over 2 times minus 3y is like minus 9 over 2. So tidying this up, you could of course use decimals if you prefer it, but the fractions will work as well. If I add 1 to both sides and I collect the y's up on the other side, that would mean that 5 over 2, and this is like minus 4.5 minus another 2, that's minus 6.5. If I plus that across, or 13 over 2y is what I've got, then what that tells me is that if I times both sides by 2 and divide both sides by 13, y is equal to 5/13. So that's the solution for y. And then I can take that and put it back in and find the solution for x. So well done if you've already done this. And if I put it back into here, this might be the easiest one to substitute it into. So x would be equal to a half 1 minus 3 times 5 over 13. So that would be 15 over 13. 1 minus 15 over 13 would be minus 2 over 13. And a half of that would be minus 1/13. That's the value of x. Now, bearing in mind these questions, if you think these are looking quite nasty, these questions could be on a calculator paper as well. So probably more likely when the solutions aren't as nice, but just bear that in mind. I am a little bit, as I said, mindful of the time. We'll quickly do this one and then we'll start looking at the method of elimination. So this one here, very similar approach. Let's make A the subject. So A is equal to a half, lots of 5b plus 1. And I do appreciate these are a lot more challenging looking answers, so do feel free to ask any questions as we go. If I times this out, I'm going to get that, oh no, sorry, if I substitute this in to this equation here, 3b is equal to 1 minus 4 lots of a half times 5b plus 1. So I'm replacing A in here. And what I'm going to find is that I'm going to find that 3b is equal to 1 minus 2 lots, because 4 times a half, 5b plus 1. And as I said, do feel free to share any answers and questions as we go. 3b is equal to 1 minus 10b, and then minus 2 times 1 is minus 2. Tidying this all up, add the 10b across, 13b equals minus 1. So b equals minus 1/13. Running out of space a little bit here. Okay, lovely. And then I can put minus 1/13 back into here to find A. And that'll tell me that A is equal to a half lots of minus 5/13 plus 1. And that will tidy up to 4/13. Okay, and that's the value for A. So I'm keen to move on, but please do ask any questions if you want me to recap anything, go over anything, or double check any answers. So here we go. Do let me know how you're feeling with that so far. So I know some people, this is a topic you've seen before. For others, that might have been new, or it might have been a bit of an extension on what you've covered before, as the answers were a little bit trickier. But if you can let me know in the chat with just a 1, 2, or a 3, how confident you're feeling with that process. And this is a really important idea, actually, with the new exams. Process marks are really important. So where you used to have method and answer marks, understanding and showing a process is a new kind of part of a lot of the mark schemes, and it's really important that those steps are clear. Thanks for those that have kind of suggested how you're feeling, but do let me know if you know that you're not 100% or you want to check anything. Lovely. So what we're going to do now, let's look at this exam style question for this one. So it says, what are the coordinates of the point where the lines with equations x plus y equals 7 and x minus y equals 3 intersect? Circle the correct answer. Now you can, for this, do method of, like, you can kind of go through process of elimination, plug them both in and see what works, or you can solve this simultaneously. So if you're a little bit still unsure, no worries, we'll go through this together. So x plus y equals to 7. If I make x the subject, then x is equal to 7 minus y. So I've just made x the subject here. And what I can do is I can plug that into the other equation. So 7 minus y, which is x, minus the other y here, is equal to 3. So that means 7 minus 2y equals 3. If I rearrange this, so for example, I minus 3y and I add the 2y across, I get 4 equals 2y. So that means that y is equal to 2. Okay, so if y equals to 2, what I can do is put that back into here and find what x is equal to. So x equals to 7 minus 2, which is 5. So the pair of coordinates that work are 5 and 2. So this is the solution. Well done. So what you could have also done is you could have actually just substituted this for x and this for y into both equations and checked which pair worked in both. That's another way you could have done it. Depends on how the question's designed, but that would have been a possible way of doing this as well. So moving this on quickly, let's have a look at another exam question here. So solve the following simultaneous equations using an algebraic, not graphical method. So basically like we've just done. So I'm going to quickly whiz through this. And again, I'm going to use the first equation to make x the subject. So 4x would be equal to 2 plus 3y, if I move the 3y across. So x would be equal to a quarter of 2 plus 3y, if I divide both sides by 4. Now, if I replace x in here with all of that, that would be 6 times a quarter lots of 2 plus 3y minus 5y is equal to 1. And again, do feel free to work ahead of me. So 6 over 4, which is the same as 3 over 2, which is the same as 1.5, times 2 plus 3y minus 5y equals 1. And remember, all this work to start with is just going to find us the value of y. So if I times this out, 6 over 4 or 1.5 times 2 is 3, because remember it'd be the same as 12 over 4. 12 over 4 is 3, plus 3y times 6 over 4 would be 18 over 4, which is the same as 9 over 2y, minus 5y equals 1. If I tidy that up, that's like 4.5 minus 5y. So that would be minus a half y equals, if I move the 3 across, minus 2. So that tells me that half y equals 2. So half of y is 2. So if I double both sides, 1 whole lot of y is equal to 4. So I found the value of y. Now, although I say this is only half of the answer, it's the majority of the work is done, because all I need to do now, remember, is plug this value of y back in, probably to here would be easiest, to spit out the value of x. So x is equal to a quarter, 2 plus 3 times the y value, which was 4. And so that would be a quarter of 2 plus 12, which is 14 divided by 4, 14 over 4. So you could leave it as that. That's the same as 7 over 2 or 3.5. So that's the value of x. So Let's double check and make sure that's all okay. But have a little look at what I solved, because this was, again, a nastier one. The x value was the harder value, so the x value did have to be fractional. So please just check that that makes sense. What we're going to do now quickly is go on to elimination, which is a method that a lot of people prefer or perhaps a little bit more familiar with. So this was all done by method of substitution, and we looked at some quite challenging questions. So very well done to all of you there for working through and following that. Solving by elimination now, I'm going to talk through the process. So what we do to solve simultaneous equations by elimination, what we do is we scale the equations. So we scale the equations. So either x or y have the same coefficient. And feel free, again, if you've done this before, to work ahead of me and try and solve this yourself. So it's a different method, a different setup, and we'll see how we go. So we scale equations, so either x or y have the same coefficient, which means the same number in front of them. Coefficient. And then what we do is we subtract, in a lot of cases, add or subtract. We basically eliminate. So for this one, we could subtract one equation. And if we've scaled them so they're the same, you subtract one from the other to cancel it out. So subtract one equation from the other and solve. And I will obviously go through this, but do feel free to try it out yourself first. And then, as always, for simultaneous equations, substitute the solution back in to find the other value. Substitute solution to one equation and solve the other. So here we go. We'll go through this example. And well done if you've done it. No worries. Welcome if you've just joined. I'm just going through the second method that we're looking at for simultaneous equations, which is solving by elimination. So far we solved how to cover simultaneous equations, how to do it by substitution. This method is by elimination, which I'm going to go through now. So these are the steps. And what we do is we want one of the coefficients of either x or y to be the same. So I think the easiest thing to do is times this first equation by 2. So I get an equivalent equation. If x plus 3y equals 4, then that means that 2x plus 6y must equal 8. Is everyone happy with that? So that's just a scaled version of the first equation. So the other equation I've got is that 2x minus y equals 1. So I've just kind of created another equation, but the coefficient of x is the same. And what's really nice now about this is that I can subtract one equation from the other and eliminate all the x's, get rid of the x's from the problem. So 2x plus 6y must equal 8, but 2x minus y equals 1. So if I take the whole of the second equation from the first one, 2x minus 2x, there's no x's left. 6y minus y would actually be 7y, and 8 minus 1 would equal 7. So y equals 1. So this has come out quite nicely. And again, I found a value for y now. So I can plug that back into one of these equations to find the value of x. So if I plug it back into this first equation here, x plus 3y, 3 times 1, is equal to 4. X plus 3 equals 4. X must equal to 1. So there's my solutions. There's my pair of solutions. So you could give it as a coordinate pair, 1, 1. Or you could think of it as, say, x equals 1, y equals 1. But there's your solutions, the values that work in both equations. So that was using a method known as elimination. And we'll look at another couple of examples here. And we'll look at some sort of slightly trickier ones as well. So let's move this on so we can do that. So this one here, 5x plus 2y equals 1. and 2x minus 5y equals -1. Now, this is a bit trickier because we might sometimes have to scale both equations. So my advice here, if we were going to say, for example, make x line up again and be the same coefficient, I could times that first equation by 2, the whole thing by 2, and times the second one by 5 to find the sort of lowest common multiple. So 5x plus 2y equals 1. That must mean that 10x plus 4y equals 2, because I've just doubled that scenario, times it all through by 2. I've generated an equivalent equation, but what I'm doing is I'm making the values of the coefficients of x be the same. So if I times this one through by 5, that would also be true, that 10x minus 25y equals to -5. Okay, so what we can do here is, again, subtract one equation from the other. 10x minus 10x is no lots of x. 4 minus -25, or 4y minus -25y, is actually 29y. And 2 minus -5 is 7. So 29y equals 7 means that y is equal to 7/29, because I've divided both sides by 29. Oh, brilliant question. Why do you have to multiply by 2 and 5? So you basically want, for this method of elimination, this is a different technique to the substitution one, to get either the number in front of x in both equations to be the same, or the number in front of y to be the same. So I've thought, well, 5 and 2, what do they both go into? They both go into 10. So if I can scale it so that they both start with 10x, then I can subtract them and it will get rid of the x's. It will eliminate the x's. So if I've got something that starts with 5x, if I double that scenario, I've got the same sort of situation, but I'm starting with 10x. I'm looking at like 2 lots of it. If I have something that starts with 2x and I times it by 5, I've got 10x. So I'm scaling these equations so that the number in front of x is the same, so that when I take them away, it cancels all the x's out, eliminates x, and allows me to find y. And then what I can do is put that value of y back in and find the x value. So it's a really good question, because it's actually at the heart of why we do this method. We scale them in order to eliminate. So the reason I multiply it by 2 and by 5, one equation by 2 and one equation by 5, is it would then allow both of them to have 10x in them, so that when I take them away from each other, the x's go, they eliminate, and I just get left with one unknown, y, which I can solve. So that's why we multiply by 2 and 5. So hopefully that's nice and clear, but thanks for that question. And what we'll do, we'll carry on. So I found the value of y now. It was a little bit more challenging, this one. And then what I'm going to do is substitute that back in to find x. So for example, if I were to put it back into maybe even this equation here, 2x minus 5y, 5 times y, which was 7/29, is equal to -1. And if I add that across, I would get 2x is equal to -1 plus 35/29. And then what I get is I half that, and I get that x is equal to 3/29. Okay, so these solutions were slightly trickier looking, but the method was, again, to eliminate by scaling the equations, cancelling and substituting it back in to find the other unknown. Right, I am a little bit mindful of the time, so what I'm going to do is I'm going to, obviously there are some other questions here we can try, but I'm also keen that we have a little look at some exam questions as well. So what I'll do is, if I move on to an exam question of the method of elimination, just let me know how you're feeling with the process of elimination, of scaling and taking them away. I know this is something that some people will have done before. You may have even learned it before you learned substitution, and for others this might be brand new. So just let me know 1, 2 or 3 how confident you feel with the method of elimination, and then what we'll do is we'll look at Oh, very good question. Is there a method which is considered to be more accurate? No, but there are methods. So for example, substitution will work with harder equations as well. You can't always use elimination if it's, for example, a quadratic. But for these kind of questions, no, it's whatever one you prefer. So they're both equally accurate, although I would say the method of elimination is limited to this style of question. Okay, so that's a really good question there. Right, let's quickly try this one now. So solve the simultaneous equations, 3x plus 2y. And we'll go through this and then I'll try and answer any of the other questions that have come in. So 3x plus 2y equals 4 and 4x plus 5y equals 17. So let's have a little look at this one together. So I would again scale them so that the x's are the same. So what we could make, that the first number they both go into, 3 and 4, is 12. So we could times that first equation by 4 and that second equation by 3. And then the coefficients of x would all be 12. So I'd have 12x and 4 times 2y is 8y and 4 times 4 is 16. And then the other one, 3 times 4x is 12x, 3 times 5y is 15y, and 3 times 17 is 51. And then if I take one equation away from the other, 12x minus 12x is no x's. 8y minus 15y is minus 7y. And 16 minus 51 is minus 35. And if I divide both sides by minus 7, I get that y is equal to 5. So that's a lot of the work done there. Now I know that y is equal to 5. I can plug that back into any of the equations to work out what x must be. So for example, if I plug it back into this first equation here, 3x plus 2y, and y is equal to 5, 2 times 5, must all equal 4. So 3x plus 10 must equal 4. So 3x, if I minus 10 from both sides, equals minus 6. And then divide both sides by 3, x equals to minus 2. So my solutions are minus 2, 5. X equals minus 2, y equals 5. They're the pair of values that work in both of these equations. Okay. Well done if you got that, that's lovely. And that was using, again, the method of elimination here. So you could have used substitution as well, but by scaling it to 12x and taking them away, I eliminated x from the equations, found y, and then put y back in to find the value of x. And I got my pair of answers. So well done, that's lovely. Now, this question already looks very wordy and kind of confusing. Let's have a little look. So what we've got here, so C pounds for a pair of curtains, B pounds for a set of blinds. On Monday, she completes 10 pairs of curtains, 2 sets of blinds, and is paid £35. This gives the equation 10 times C, 10 times the cost of the curtains, plus 2 times the cost of the blinds equals £35. On Tuesday, she completes 5 pairs of curtains and 6 sets of blinds and is paid £30. So this one's just a little one marker, write an equation for this. So this is very much the same. This means that 5C plus 6B is equal to 30. So that's actually quite doable. We've not had to solve anything. Just like how this bit was done as an example, the equation was made into an algebraic scenario. We then can do that for this bit. Yes, I do A-level. We've actually got an A-level web class starting in about 10 minutes. So we'll be doing that very shortly. I'm going to be looking at the binomial distribution, I think. So yes, that will be coming up. Right, so that's the equation. That's the answer to the first question there. Now, the next bit, it says solve the 2 simultaneous equations algebraically to find the amount she paid for each pair of curtains and each sets of blinds. So the 2 equations we've got, what do we have here? We had 10C plus 2B equals 35. No problem, that's great. And then we have 5C plus 6B equals 30. And then if I wanted to eliminate this, so 10c and 5c, and I could double this one. So actually, what might be easier here? Yeah, if I double this one, 10c plus 12b equals 60. 10c plus 2b equals 35. Yes, I believe so. I'm just checking the chat as well, and I'll try and answer these questions in a second. But yes, I'll be doing an A-level web class shortly, in a few minutes, and I'll also talk a bit about Snap Revise on there and show you the platform and the resources we have with, you know, videos and web classes that I've run previously. So that's cool. So what we'd get here is 10b is equal to, and 60 take away 35. So 25, and then B is equal to £2.50, and there we go, and we can plug that back in and find C. And I'm just mindful of the time, but if you plug that back in, I believe we find that C is equal to £3. Well done. So well done if you got £2.50 and £3 for C and B. That was a pair of simultaneous equations we could solve by elimination. So what we've done, that was a very ambitious web class. We got through a lot there. We looked at what a set of simultaneous equations are. So two pairs of equations with two unknowns, and their solutions work in both equations. So we find an answer for X and for Y. The two different methods we looked at were substitution and elimination. So substitution meant writing one as the subject and plugging it into the other, finding that, and then getting the other value. Elimination meant scaling it so that they had the same coefficient, so we could take them away and then eliminate one of the unknowns, but then remember to go back and also find that value as well. So we get two answers for simultaneous equations, a value for X and a value for Y, or A and B, or whatever the variables are being called. So we need two pairs of equations for two unknowns. And these are the two approaches we could use, substitution and elimination. And they're definitely methods worth practicing. The other thing we briefly mentioned is you can also use a graphical approach. So if you're ever given the graphs for simultaneous equations, the answer is simply where they cross each other. You just find that coordinate and that gives you the value for X and Y. So very well done. I will try and answer any questions, but I am mindful of the time. We've got an A-level web class coming up, and I will be talking a little bit more about Snap Revise on there and the different services available and resources available on the site. But do feel free to check out the Snap Revise website if you haven't already, as the content is all created for the new GCSE and A-level courses. So it's really geared up to exactly what's going on in education in the UK at the moment. So it's a really good resource and platform to be using. Do set reminders for the upcoming web classes that occur on the Sundays throughout the summer and beyond. And hopefully we'll see you at one of these in the future. Really well done to everyone. And thank you so much for all the questions and answers today. That was brilliant. A big, ambitious topic, but an important one for GCSE. So really good that everyone took part so well. I know we did some tricky questions there, but thanks very much for asking great questions and also sharing your answers as we go. Well done, everyone, and keep well, and hopefully see you at one of these sessions again. I'm going to just stop sharing that there, but want to say thank you again, and that was great. Hopefully see you at a future web class. That would be brilliant. Cool. So I'm going to stop that there, but have a good weekend and well done again. Thanks, guys. No worries. Take care, guys.